Hello! This presentation is about balancing chemical equations. I'm just going to show you a few of the quicker, easier balanced equations and kind of give you the highlight of them all. You can find this sort of stuff on page 282 to 288 in your textbook. Okay, chemical reactions in general are chemical changes, and we show what these chemical changes are by writing the reactions out. So technically, chemical reactions are when the atoms of one or more substances are rearranged to form a different substance. It's kind of like this kid with all the Legos here. We've got a bunch of different individual atoms, or you have a bunch of different compounds too in a reaction, and in the end we make something entirely new. So when we write a chemical equation, it looks like this top part here. It's got a few distinct parts. This arrow thing is called yield. The arrow means yield. The stuff on the left side of the arrow, or the yield sign, are called the reactants. The stuff on the right side of the yield are called the products. So the reactants are the things you put into the reaction. The products are the things you get out of the reaction. Notice other parts that are in this reaction is this little part, which we've already used before. These are the subscripts. We put subscripts in when we use our balancing, we use subscripts when we use our naming skills. And these big 2's are called coefficients. Coefficients are the things that we put in when we balance equations, which is what this presentation is all about. Now if you notice, in the picture below, I've got one zinc, two HCl's, and it will yield one zinc chloride, there's an imaginary 1 there, and one H2. If you count the dots on both sides, like we have 2 H's on this side and 2 H's on this side. We have 2 Cl's on the left and 2 Cl's on the right, and we have 1 zinc on the left and 1 zinc on the right, or the products. You can see that the number of atoms that you have on the left has to equal the number of atoms on the right. And not just that, the number of the type of atoms on the left have to equal the type of atoms on the right. That's how we get a balanced equation. Other things you might see in a balanced equation are states of matter. Do you have to have them every time? No, but I would get in the habit of doing them because they're going to be very useful. If it's a solid, we just use parentheses with an S. A liquid with just an L. Aqueous, remember aqueous is the idea that you're dissolved in water, aqueous. And G for gas. You can also see this triangle heat thing, and the triangle heat thing will usually be seen over the arrow. You could just use a triangle, or you could write triangle heat. We'll see eventually we don't always have to have it over the arrow, but that's in chapters to come. Okay. So let's take a look at our first equation. Now this is not a balanced equation, but we're going to balance it. I think the best way to start balancing equations is to create an atom inventory. That means we're going to list all of the atoms that we have. We've got cobalt, we've got chlorine, and we've got iron. Cobalt, chlorine, iron. I put them in the same order. So if we look at the reactants, I happen to have 1 cobalt on the left. If I look at the products, I have 1 cobalt on the right. Those are balanced. That's good. I look on the left, I've got 2 chlorines on the left, and I have 3 chlorines on the right. Okay, not balanced. Going to irons, 1 iron on the left with the reactants, and 1 iron on the right for the products. Now clearly it's not balanced. I'm going to give you 4 hints, or 4 things you could do to balance equations quickly, but they're not the only 4 rules. I'm just going to give you 4 basic rules, 2 of which in this video. So my rule or hint for balancing equations number 1 is to save the single elements for last. In this case, it's kind of obvious where we want to go first, the chlorines, but in some cases it won't be. And that's when we want to save the single elements. That's like cobalt, he's all by himself here. Or iron, he's all by himself here. These are the ones you'd want to save for the end. But if we look at my chlorines, they're the only parts that aren't balanced. So I need to balance the equation. Now I can't just take out that 2 and put in a 3. That does not work. The reason that does not work is because it completely changes the compound. When you balance equations, the only thing you can do is put numbers in front. You can only add coefficients. That's the big numbers in front. You can just add numbers of compounds because you've got a whole bucket of them, but you can't change the kind of compound you have. So if I look here, I got 2 chlorines and 3 chlorines. I need a common denominator of 6. So if I put 3 here and a 2 in front of this one, I now have 3 times 2, that's a multiplying, gets me 6 chlorines. and 2 times 3 gives me 6 chlorines on this side. That looks good, now those are balanced. But you can see I did mess up some other things, like this 3 does apply to the cobalt. Now I have 3 cobalts on the left, and this 2 does apply to the iron, so now I have 2 irons on the right. That's okay though, I can fix it. Looking at my cobalts, I've got 3 cobalts on the left, so I'll have to put a big 3 here for cobalts on the right. That way I have 3. Looking at my irons, I have 2 irons on the right, so if I put a 2 here, then I've got 2 irons on the left. And now my atom inventory says I've got 3, 6, and 2 of each of them. Things look good, and I've got a balanced equation. Your end answer on the test, the only thing I require is this filling in the coefficients. If you don't want to do this atom inventory, that's okay, you don't have to. You'll probably get good at it and you won't need to, but I think at the beginning you might want to start that way. Okay, let's go to a trickier one. Here we can see we've got word equations, and we need to make the words into actual formulas. That's our first step. So, I've got to write nitrogen. Nitrogen is N, but he's not just nitrogen, he's actually N2. And hydrogen is H, but he's not just hydrogen, he's H2. I'll tell you why in a second. Okay, nitrogen is N2 with a G for the gas, that's what a gas means, plus H2 with a G for a gas, yields NH3 with an L for a liquid. So here's my rule number 2, or hint number 2. Don't forget Dr. Hofrinkel. And notice how I wrote it with some lowercase and some uppercases. So you can see here that I wrote it as N2. I can't just write nitrogen as N or hydrogen as H because you'll never find them that way. Nitrogen, as his Lewis dot structure, is like this, and hydrogen, we know his Lewis dot structure is like this. And when we look at them, they've got just one electron, and what they want to do is they want to complete their outer octet, and they will be so rampant just to try to complete their outer octet that they'll find another nitrogen to hook up with it and make a triple bond for the nitrogen. Or like hydrogen, we'll find another hydrogen and hook up. So what happens is you'll never have just one nitrogen atom, you have a lot of them, and they always find a partner to hook up with. So that's why you'll never find nitrogen by itself, you'll always be N2. So if you have just nitrogen, you have to write N2. You never find hydrogen by itself, you'll always be H2. Now if hydrogen hooks up with somebody else, you don't need to have 2 hydrogens there, you just need as many as the name suggests. But if it's just hydrogen, you need 2. And if you look at my hint, don't forget Dr. Hofrinkel. H is for hydrogen, N is for nitrogen, and this other part is to remind you that oxygen, fluorine, bromine, iodine, nitrogen, and chlorine are all things that need the 2. They're technically called diatomic molecules. Diatomic 2 atoms that make up the molecule. We never find them by themselves. Don't forget Dr. Hofrinkel and P4S8. P4, you'll never find phosphorus by himself, he'll be 4 phosphoruses together, so he can be happy. And you'll find sulfur, he won't be by himself, he'll be S8. So these are just things to remember when you're writing just those elements of phosphorus or sulfur. Okay, now that we got that hint, we need to balance the equation. That means put the big numbers out front. I'm going to make an atom inventory. I just have N's and H's. Number of N's on the left, I have 2. Number of N's on the right, I have 1. Number of H's on the left, I have 2. Number of H's on the right, I have 3. So now I've got to figure out how I want to balance equations. I can kind of go with this any place that I want, but I'm going to go to one that's the trickiest. That's another way you might want to go. H's 2 and 3, those are odds and evens. I got to make it even out. So I'm thinking 6. 6 is a common factor between 2 and 3. So if I put a 2 out front of my NH3, I now created 6 hydrogens. And if I put a 3 out front of my H, now I've created 6 hydrogens, and they're happy. Of course, I did add numbers, so now suddenly I've got 2 N's, that's 2 N's. And my H's are 6, so if I look, I have balanced the equation with 2 N's and 6 H's. I can put a 1 here if that empty line kind of makes you uncomfortable, but you don't have to. So now I have a balanced equation here. Next. Alright, so hopefully you took notes for all that because I think the 2 hints are very important. We're going to add 2 more tomorrow in class. I'd like you to try these equations and write them answers in your notes. I'll be looking for them tomorrow, and I'll go over the answers with you tomorrow also. So do the best you can. You've got to take the words, and write them into formulas, and then balance the equation. Good Good luck!